In the ongoing saga of this Brown Atelier 3 restoration, I came up with a little requirement that created a bit of a challenge. And let me tell you what it is. I wanted to receive a station. It's actually a station I listen to quite regularly, which is on 101.6 megahertz FM. Now that's my go-to station, which I'm sure a lot of people have. You get home, switch on the radio, and you expect it to be on there. Now the problem I have is that this particular radio, like many German tube radios, has an FM extension from 87.5, I believe it is, all the way along, and it stops at 100. Now this is pretty usual, because that's what the range was back in the 60s and 50s, and later on it extended to 102, 104, and then finally to the 106 or 108 that we get now. 108. Now they've come up with a lot of different ways of doing this. There's a way of doing a frequency shift on your aerial signal. You basically take your dipole antenna signal from there, put it through a frequency dropper, and it would drop 10 megahertz of everything that it receives, and then feeds that signal into the radio. So, anything on 108, you'd get at 98. However, if you go down to the bottom of the dial, anything on 88 would get at 78, so you wouldn't be able to reach it. So it's very fussy, and I didn't like that idea. And so I had another one, which is nothing new, but I have never tried it before, so I'm going to document it here. I saw these alignment instructions for this radio, and it gives you the instructions for aligning the IF, both on AM and FM. And one thing I don't like to do is mess around with the FM alignments, because I don't have the equipment going up that high. I have, a scope that goes up to 50 megahertz. I have a signal generator that I think produces 25 megahertz. So producing signals in the 100 megahertz, 108 megahertz, 90 megahertz, that's not something I can do. And it's certainly not something that I'm too keen on changing too soon, because the equipment is just something I don't think I'm going to use much. And I'm quite happy with the clutter in my workshop as it is. So I was looking at these instructions, and I noticed that they have the RF alignment for FM, where they tell you to put in a signal into the radio, and then you would tune your radio to your dial pointer to, say, 88.5. You'd set your signal generator to 88.5, and you change L2 and L3 for maximum signal. Fair enough, no problem. That's what I wanted to avoid. These coils, I mess as little as possible with FM coils for various reasons. And anybody who's done this will probably have gone through the saga of breaking ferrite cores and all that sort of crap. So I skip to the next one. It says, look at the final one, the 100 megacycles. Set the oscillator or the generator to 100 megacycles, and you tweak capacitor 18. Now, these capacitors on this particular set are actually very, very easy to tweak. They're not gunked up with the wax. They're not sealed. They're actually pretty easy to tweak. And one other thing I noticed is the actual screw on the capacitor, the adjustment screw on this trimmer, is grounded. So that means you don't have to worry about using ceramic screwdrivers or adjustment tools or anything like that. You could just use a screwdriver. It's ground anyway. But I have made these things up before, so I do have some wooden ones and some plastic ones, but it's very, very simple. And what it basically tells me is that I can adjust the top end of the scale. And so what I wanted to do is see if I can, put something in at the frequency that I want, and extend the end of the scale that far up. And if I do that, what happens to the low end of the scale? There is one station on 88.0, which I sometimes listen to. So for me, that's sort of the bottom end of the range. There's one station, the one I want, is at 101.6. So I figured, right, I need to extend this to 101.6. And it would be easy enough. You just put your tuner at the end of the dial, and you tweak your capacitor to try and see, if it gets any closer, if you start hearing the station that you expect to hear. Then I thought, okay, let's go one step further and let's get this a little bit more precise. And the way to do that is using something a lot of people have, actually. One of these things. This goes into the iPhone. It actually goes into the older generation iPhones, because that's the connector they've got. And it allows you to play your iPhone through your FM tuner. It basically is an FM transmitter. I now no longer have the old iPhone, so this thing is useless, but I do have another one, which is in a more DIY state. It's been hacked because I wanted to extend the antenna, and in the middle of all that I can't find the casing, so it's in its raw form, which is not bad. It works. So what I figured I'd do is I'd send a signal, an audio signal, from my iPad at 101.6 megahertz, and I'd be able to tune that capacitor to the exact highest point, highest reception, and therefore I'd be able to test where it is on the dial. I'd also then be able to test the correspondence between the dial and the frequency of any frequency, because this thing is actually very accurate. Once you get this thing working, it's incredibly accurate. You get it to 0.1 megahertz and it works just fine. So I figured I'd do that. I have a signal generator app on my iPad, so I can produce an audio signal of any frequency that I want, say a 1 kilohertz or 600 hertz or whatever, and I would then send it through this and I would pick it up on the radio. So let's see how we get on with that. So here's the app. It's the EE Toolkit, and it's an app that I actually use quite a bit because it's a great set of tools and information for the hobbyist, and it's very, very well done, and it gets updated occasionally, so you always have information at your fingertips. And it has this function, which is basically a function generator. I've set it to 1 kilohertz. You can set it to any frequency you really want, up within the audio range, up to 21 kilohertz. And you can produce a sine wave, square wave, triangular, sawtooth, whatever you want, really. And you can even do a sweep on here. But what I want is I've put in a 1 kilohertz sine wave, and that's what you get. If I adjust the frequency, there's a 500 hertz, there's 2 kilohertz, there's 1 kilohertz. Stop that for now. Now that's coming out of the internal speaker, and what I want to do is transmit this through the FM band, or to the FM band, and pick it up on the radio. So let's connect it and I'll show you what I've done. So what I've got here now is I've got exactly the same thing, except to the headphones I've connected the little transmitter, which I've actually set to 100 megahertz. And if all is well, it should be transmitting right now. Well, as soon as I press start. Put a bit of volume there. It's on FM. Whoa. There we go. 100, exactly. I can change that just to show you that it is what we expect. There's the 500 signal. So I'm now receiving exactly that frequency, or that tone, on 100 megahertz. And just to make it more precise, or to allow us to adjust it a little bit better, I have the AC voltmeter connected. So I can use this to adjust this AC voltmeter is connected to the output, to the speaker, across the speaker, and I can then peak it, and I'll know exactly where the peak is, which is over there. So this particular one then is at, well, near as damn it, slap on 100. So what I want to do now is I'm going to increase that frequency, the transmit frequency, to 101.6, and I'm going to tweak the capacitor C14. I'll show you where that is. When we look at the instruction sheet, it's actually not C14 because I want to extend. Basically, this thing's telling me how to correct the 100 megacycles, 100 megahertz, and it tells me C18. That's the one. So when I want to adjust the 100 megacycle, the top end, I'm going to go and look for C18 and adjust that one. And that is, if you look at this drawing of the top of the FM tuner, this is the top of the FM tuner, the can in which the first stage of the FM tuner is set. You can see that C18 is that guy over there. So what we need to do then is to look for C18 on the can. I can tell you now that the tuner is actually the other way around from the front. So to make it easier, this is what we're looking for, and that is C18. So if we go over to the can, I'll show you. So there's the FM tuner can, and if we follow the drawing, we had 1, 2, 3. So 1, 2, 3. It's that guy over there. Okay? So that's the one I need to tweak to adjust the top end of the range. All right? Now, what I could do is I could simply, you see, you could actually probably see the screw in there. It's one of the easy ones. Now, what I could do is I could put the transmitter on 101.6, which is where I want to go to, and do it straight away. But I'm not sure whether I tweak clockwise or counterclockwise on the capacitor to go up or down. I don't want to send it all over the place and then not be able to bring it back. So what I'm going to do is I'm going to just, we have the transmitter on 100 megahertz. I'm going to up it very slightly. So I've got this thing set to 100. I'm going to set it to 100.5 and leave it transmitting the same 1 kilohertz signal at 100.5, and I'm going to see what happens when I tweak the capacitor, whether it goes down or up. Okay, so now I'm transmitting that exact same signal at 100.5, and I'm going to change the tuner and see where exactly it is that I'm getting that 100.5. So at the moment it's exactly at 100. Yep, it's up. So I want to bring this down lower to 100. So I've got 100 on here, and I'm going to tweak that to get 100. Okay, counterclockwise brings it down. Alright, so if I put that, what I've seen here is if I turn that counterclockwise, it's brought my 100.5 megahertz signal to show on 100. And it's exactly what I want to do. I want to bring the 101.6 to show on, say, 100.6. Okay? So what I'm going to do now is I'm going to set the transmitter for 101.6, and I'll be watching the dial and decide where I want it. I think what I'm going to do is I'm going to put it at about there. Just a little bit to the end, so not right at the end. I'm going to give it a little bit. I'm going to put it there. And I'm going to tune the transmitter to 101.6, and that on the dial is where I want to get 101.6. Okay? Let's try that. So 100.8, 0.9, 101, 5, 6. There's 101.6. So we have our signal generator happily transmitting that tone at 101.6. Come back to here. And I will tweak down. Tweaking very gently. You don't want to mess with these things too much. Oh, I can start hearing it. Okay, I've got it there. Now, do I have it in the optimum position? Well, we'll see. Go to the voltmeter, AC voltmeter, and I'm going to tweak it to its peak. There we go. There we go. So, what this tells us, let me put the volume down. This tells us that I have exactly 101 megahertz actually tuning on that spot on the dial, which is 100.6 approximately. Okay, so if I turn off the generator and I turn off the transmitter, what do I get on 101.6? Perfect, that's the station I want. That's exactly what I wanted. Brilliant. Now, there's one more requirement here, and that is that there is a station on 88 that I pick up. And 88 is probably no longer 88, as we can surmise from what this trimming has done. I do not really want to change those coils, because to adjust the lower end, I could raise the lower end or extend the lower end. It says here how to do that on 88.5. And you have to mess with antenna coils L2 and L3. Not antenna coils, but these are the oscillator coils. I really don't want to if I don't have to. So let's see if I've lost 88. So what I'm going to do now is I'm going to set the transmit frequency to 88. And we'll try that signal again and see if we can receive it. So it's now transmitting on 88, and I bring this to the other end. Now normally I would get it there. There it is. There's my 88 now. Okay, so 88 is within, and we lose it, yeah. So 88 is actually completely within the range. So what I've done here is I've actually saved my reception of the 88 megahertz channel, which is what I wanted to do, and I've brought in the 101.6 megahertz station, which is what I wanted to do as well. So I've extended the range at the top end at the cost, at the expense of the lower end, but because the part of the lower end that I've lost is not important to me, the overall result is exactly what I wanted. And unless there's something I'm not seeing here, I've done nothing to the selectivity or sensitivity of the set. I may be wrong, but first of all, audibly it doesn't sound like it. And looking at the schematic, you know, it's giving you an instruction on how to extend the range, and it doesn't tell you about adjusting anything else like the oscillator itself. Or I really don't think I've done anything else to the set, which, and I hope I haven't. I do know that because that 100 was spot on, I've got that as a reference, I've moved exactly one component, I've tweaked one component, and I believe that I can bring it back to its original position using the same method but backwards. So back to 100 reading 100 if I have to. All right. The other thing that I was wondering is just how far this can go, and I want to show you something real close up. This capacitor that I've tweaked there, I believe there's quite a bit of leeway one way and the other. This one, it's actually almost out of the can. So it seems to be almost at the limit of where it can tweak to. I believe I'm decreasing the capacitance, if I'm not mistaken. This capacitor is in parallel with the FM tuner capacitor. And so, if I reduce it, it's bringing the total capacitance down. I believe it's almost at its limit. So I'm not going to test how far I can play with this. All I can say is that if I had a station on 102 and 102.5, I would try it. I don't want to go too far on this because I don't want the screw to come out of the cap and then I have to dismantle everything and put it back in and probably not get the same values. So I'm not going to mess around too much with that. I'm going to consider myself lucky and enjoy the set. So far, this little guy saved the day. And it really is great to be able to use 21st century technology when adjusting a 20th century, mid-20th century piece of equipment. Right, bye for now.